to study functions in great detail, but for the moment, let's just consider when you've got a case of a function and you want to graph the resulting surface. And the case that is usually considered is where z is a function of x and y. Right? What this means then is that for each point x, y, right, there's one value z. This is going to result then in a surface that is located above the xy plane. And so if you've got an equation in x, y, and z, and you can solve it for z, you can then start graphing this by plotting points if you want, by first solving it for z, and then looking at what happens at various values of x and y. There are a couple of other possibilities, all right? Here's z as a function of x and y. We could also have y as a function of x and z. Say y is g of x and z. In this case here, given a particular x value and a z value, you would have one specific y value. You'd end up with a surface that has for each x, z, one y value. The surface consequently would lie over or perhaps above it below, but nonetheless, each point xz, there would be a point here that would lie above or below the xz plane in the y direction. And of course, the third possibility is that x is a function of y and z, in which case, for each particular pair yz, there would be a unique x. And so if this is x, y, and z, the graph would lie somewhere out here. An example that we've already looked at of this form right here is, let's say z is equals to x squared plus y squared. For each x and y, there's exactly one z. And in particular, if we take a look at a point xy here, the z is positive. If we look at the traces here, for example, when y is equals to 0, we get a parabola in the x z plane. When x is equal to 0, we get a parabola in the yz plane, and the resulting surface is going to look like this. Right. So that above this particular point xy, there's going to be exactly one point here on the surface. So here's an example of a surface that we've looked at already that is where z is a function of x and y. These other surfaces, other types of surfaces can be drawn. Keep